Hey everyone, welcome back to the DSA roadmap series. In the last lecture, we explored hash table and today we are moving on the heap and priority queue. Heap and priority queues. Okay, one of the most efficient data structure for priority based operations. So without wasting our time, let's get started. The first question is, what is heap? A heap is a specific type of binary tree that satisfy the heap property. So there are mainly two properties. The first one is a maximum heap and the another one is a minimum heap. Maximum heap means the parent node is always greater than or equals to its children. And about the minimum heap means the parent node is always smaller than or equals to its child, or we can say children. Okay, heap are used in priority queue scheduling algorithm and heap sort. They allow us to efficient extract the maximum or we can say minimum element in O not log n times. Make sure to remember this. Okay, it's important. Okay, the next question is like, what is a prior queue? It means a prior queue is an abstract data structure where elements are proceed based on the priority rather than order. Okay, it can be implemented using a heap to ensure efficient insertion and deletion. That is efficient insertion and deletion, or you can say delete. Let's take an example. In a task scheduler, high priority tasks are executed before lower priority ones, even if they were added later. Okay, I hope you get what I mean to say to you. Okay, the next is that is operation on heap. That is the key operation. Okay, the first one is that is insertion. For time complexity is O not log n. It's basically insert the element at the last position and heapify up. Then deletion, or we can say delete, the same complexity that remove the root element and heapify down. Then heapify O not log n again, that process of maintaining heap structure after insertion and deletion. Means after these two processes executed, this process is started. Then the last one is that is peak, that is the time complexity is O not 1. Get the maximum or we can say the minimum element without removing it. Like we don't have to remove anything and we get the value. Okay, the application of heap is very important. That is, it's widely used in Dijkstra algorithm, that is shortest path in graph. We will explore it in the upcoming lecture. Then Huffman coding, that is data compression. Then priority scheduling in OS, or we can say operating system. And then heapsort algorithm, that is sorting in O naught n log n. Okay, so that's it for today lecture. You will learn the basic of heap and priority queue. There is operation and application. In the next lecture, we will dive deeper into the heap implementation using C++. Okay, so make sure to like, share and subscribe for more DSA content. See you in the next one. Bye bye.